In this video, we're going to go through an example of a right tail test, and that unfolds in scenario 2. So I'm going to start off with step 1 by writing my two hypotheses. The null hypothesis, HO, is still that mu is equal to 43 grams. However, now the alternative hypothesis, HA, I'm going to scroll over so we can remind ourselves of what was unfolding in scenario 2. This person thought that the population mean was greater than 43 grams. So that is our HA. Our HA is that mu is greater than 43. Remember, the equal sign should always be in HO. So now moving on to step 2, we are going to calculate our test statistic, and we're using the same formula that we used in scenario 1. X bar minus mu divided by sigma divided by the square root of n. Don't get too caught up on the formula now. This lesson is about mastering and understanding what the 5 steps are and putting them into practice. As we go on to the next lessons, we'll look at what the different test statistic formulas are. So for step 2, our X bar in scenario 2 was 45 grams. Everything else is still the same. So we have 45 minus 43 divided by sigma is still 12 and n is still 100. So this comes out to be a positive 2 divided by 1.2, which gives us, and when I round to 3 decimal places, 1.667. So now for step 3, I am going to determine my critical value and draw my rejection region. We are still using the same alpha level of significance equal to 0.05. This is a right tail test because the inequality in HA points to the right. So now this time we will have the area of alpha, 0.05, completely on the right side of our bell curve, a right tail test. Remember that the bell curve is symmetric. So in our last example, where the 0.05 was on the left, our critical value was a negative 1.645. Here it will be a positive 1.645. And you could confirm that by going to your statistics tables, and you'll see that the z-values of a positive 1.64 has a left area of 0.9495, and the z-value of a positive 1.65 has a left area of 0.9505. We're looking for a left area of 0.95. That's coming from 1 minus 0.05, since the total area under the curve is 1. And so to find what our critical value is, since both of these values are equidistant from 0.95, we would average them together. So adding 1.64 and 1.65 and dividing by 2 gives us a positive 1.645. So now we have our rejection region. That's the shaded region on the right. With the rejection region always needs to be shaded. And we have our critical value. Step 4, we are going to make our decision. So we're going to take our test statistic of 1.667 and drop that into our picture. 1.667 is a little bit bigger than 1.645, and so that falls into the rejection region. And so we reject HO because this test statistic falls into the rejection region. So now that we have made our decision to reject HO, so I've put an X on HO, that means we are accepting the alternative hypothesis, HA. So now we are ready to write our conclusion. We need to discuss our level of confidence. So with what % confidence are we? If our alpha is equal to 0.05, our C, our level of confidence, is equal to 1 minus that. So we're still at a 95% level of confidence, 0.95. So we can say that with 95% confidence, we are rejecting HO. And so we are saying that there is enough evidence to support HA. So we will say there is enough evidence to support. And I'm not just going to write HA, we're actually going to talk about what HA is. So we are supporting that, and we'll go up to step 1 to remind ourselves of what HA is. HA says that the population mean weight of a candy bar is greater than 43 grams, and so that's what we'll put here. So in conclusion, we're saying that with 95% confidence, there is enough evidence to support that the population mean weight of a candy bar is greater than 43 grams.